Okay, so last but not least, maximum and minimum. So as you're doing max and min, this is going to be very simple, okay? We know max and min for certain things, like we know with sine and with cosine, the maximum value on our graph was 1 and the minimum value was -1. We've already discussed that when we graphed it, okay? Go back and look at your graphs. With tangent and cotangent, if you remember, our graphs had this nature for tangent, this nature for cotangent. So if you notice, they go toward infinity and negative infinity. So with tangent and cotangent, there really were none on the maxes and the mins. There would be no max or no min because there's no largest element. Remember, the reason we had largest elements with sine and cosine is because the graphs did things like this, where you had a turn. Everywhere you have a turn like that, you have, in calculus, we would call these local maxes, local mins, or you can have a global maximum or a global minimum, okay? But the max and min was 1 and -1. So, but what I'm going to want you to do is I'm going to want you to be able to find the max and the min of a problem like this. And you think to yourself, oh no, Mr. Francis, what have you done? Well, think of it like this. We know the max and the min of sine x, right? We know the max and the min of sine x. Well, the first thing you need to do is to take this inequality. See how we have a 3 sine x? The first thing you need to do is multiply the whole thing by 3. That gives you your 3 sine x right there. Okay? Now, secondly, what do we need to do at this point? Well, notice how we have a 10 added to our original equation here that we don't have here. So, add a 10 to all sides. So we have 7 is less than or equal to 10 plus 3 sine x, which is less than or equal to 13. So what does this tell me? It tells me my maximum value for y is going to be 13. That my minimum value for y is going to be 7. Max 13, min 7. Okay? Now, what about this one? Alright, so that particular graph there, well, it's cotangent. We said up top, cotangents have no max or mins. Now, that applies even with a dressed up cotangent function like you have here. Cotangent is, cotangent is cotangent. I'm sorry about that. Excuse me. Cotangent is cotangent. I'm about to cough my way through this whole thing, so I'm sorry about that. It was kind of a muffled cough there. my cotangent is going to be cotangent no matter what, so the properties will stay the same. So we have none. Okay, no maxes or mins with that. So keep that in mind as you're doing maximum and minimum. Now that's going to be the gist of it. Now when you get to something like secant or cosecant, look at your graph. Think about what the maximum and minimums would be for secant and cosecant. A lot of times if you look at your original graphs, it's going to help you determine what the maximum or minimum are, okay? It's going to help you determine that. So keep that in mind. Look at your graphs as you do this. Have a great day.